Welcome back to Physics Online. We just talked about, what was it? I gotta remember. Position versus time graphs. We're now going to talk about velocity versus time graphs. Let me switch over to the main screen here. This is an example of a velocity versus time graph. Okay. When I have a horizontal line, that means horizontal line means constant velocity. So remember, velocity is speed and direction. Okay. And so we're moving, but we're moving at a constant velocity. Okay. So horizontal line is constant velocity. Okay. A positive velocity. Now this means if I have a slope to the line. Now remember, slope. The slope of that line is rise over run, and if you calculate that out, that will tell you what your acceleration is. Okay. So if we go from 0 to 4 seconds, that is our run. So I've got 4, right? And my rise is 5 meters per second. So this is meters, this is seconds. So I've got 5 divided by 4. What is that? 1 point something, I don't know. 5 divided by 4 is 1.25. 1.25 meters per second. Okay. So I can calculate what that is. A positive line, slope on the line, means that I've got positive acceleration. A negative slope means that I have negative acceleration. Okay. So I could have a slope where I'm traveling, my velocity is 10 meters per second, and it may pretend like that's a straight line, and I'm coming down, and I stop here, my velocity is now 0 meters per second, and that would be an example of maybe braking, right? I have a negative velocity, a negative acceleration, which means I'm slowing down my velocity over time. Okay. So this is positive acceleration, and our red line here is negative acceleration. Okay. Our final one here is this slope, right? This curve. That's what I meant to say instead of slope, is that curve. That means that I have a changing acceleration. How do I do that? Well, I take a tangent line. A tangent line is just, I draw a line. Tangent, so tangent means just barely touching. I wish I could draw better. So just barely touching. Okay. If I do a whole bunch of lines here, then I've got to get it right, right? So a tangent line is just touching. I'm going to draw a line that's just touching, and then I calculate my rise over run, and that tells me for that specific spot where that just touches, that tells me that slope right there. And that's how I would calculate the slope at that instant in time. Because the curved line is changing acceleration, I can't take the whole line. I can only take it in discrete lengths. But I can figure out what the acceleration is at that point in time. Okay. Cool. Let's make sure I covered everything. I think so. Go ahead and do the concept in action. Just walk through that. Make sure you understand the whole slope thing, the whole position versus time, and velocity versus time graphs. I'm so glad you're here. I will talk with you later. If you have questions, don't forget, you can email me, or you can join me in the office hours on the Google Meet. Talk to you soon. Bye-bye.